Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of permutations and combinations, and today we are solving the examples of permutations. The first example, 5-digit number divisible by 3 is formed using 0, 1, 3, 4, 6, 7 without repetition. Total number of such numbers is, okay. So let us understand, when do you get a number divisible by 3? If sum of the numbers is divisible by 3, then the full number is divisible by 3. For example, you take let us say 12, okay. So what is the sum of the numbers? 3, which is divisible by 3. You take for example 27. Now what is the sum? If you add them, the sum is 9. Is it divisible by 3? Yes, you can divide by 3. Therefore 27 is also divisible by 3. Alright. So similarly, if you have a 327, so 5 plus 7, 12. So their total is 12. Is it divisible by 3? Yes. So if sum of the numbers, sum, SUM, the addition, okay, the sum of the numbers, if it is divisible by 3, then the number is divisible by 3. That's the logic you have to use here. Now you need a 5-digit number, okay. So alright, so what is the selection of numbers you have to make? Selection of number could be first you can have, let us say 1, 3, 4, 6, 7. Now please note 10, 10, 20, 21. So if sum of the digits is 21, then is it divisible by 3? Yes. So first selection of digits can be 1, 3, 4, 6 and 7. So this can be like 13,467, or you can rearrange this. You can start with 3, you can start with 4, 6 or 7 or 1, okay, anything. So various arrangements are there which we will calculate. Alright. What is the second selection that you have? The second selection that you can have is, you can have, see, 0, 1, 3, 4, how much is this? 8 plus 6 will be 14, not divisible by 3. Therefore, if you take 7, then that will be 15, which is divisible by 3. And another selection of the digits, selection of the numbers, selection of digits, I'm sorry. Alright. So another selection of digits could be, you can have 0, 1, 4 and 6 and 7. Alright. So count this now, 5, alright. So 11, 18. So sum of the digits is 18, therefore that is also divisible by 3. So can you think about any other selection? Alright. So you can have other selections in your mind. You add and see if the sum of the digits is divisible by 3, then the number formed using all those digits will also be divisible by 3. Well, now in case of 1, 3, 4, 6, 7, what are the different possibilities that you have in case of first selection? Let me take it as second, and let me take it as third selection. So in first selection, you have totally 5 digits and all the 5 have to be arranged. So that is 5p5. So arrangement is 5p5, which is 5 factorial, and 5 factorial is 120, correct? All right. So now next in the second, you have 0 in the first place. All right. So if you have 0 in the first place, then you cannot have a 5-digit number. So how do you calculate that? First, you calculate the total possible arrangements. The total possible arrangements is 5p5. Out of this, you have to subtract the numbers starting with 0. That means you fix 0 in the first place, and you have totally 4 places to be arranged. All right. So you have to arrange 4 places in 4 with 4 digits. Okay, you have to arrange 4 digits in 4 places, in other words. So that is like 4p4. That means 5 factorial minus 4 factorial, 120 minus 24. So that is 96, correct? So next, what about in the third case? So in the third case also, you have totally 5 digits to be arranged, but if you do this, you will get 120 numbers, but all those 120 numbers are not 5-digit numbers, because there are some numbers which start with 0, which is not a 5-digit number. So you have to fix 0 in the first place and arrange the remaining 4 places with 4 digits. So that is again 5 factorial minus 4 factorial, which is 96. Now either you have this, either you have a number with these digits, or you have the second number with these 5 digits, or you can have numbers, 5-digit numbers having these 5 digits. All right. Now, so that is or in between. So you got to add them. So 96 plus 96. So how much is that? 192 plus 120, right? That is 312. So 312, the first option, I suppose, correct? Right. So that is the first option, which is the answer for question number 1. So 312 is the answer. First, you have 120 numbers with those 5 digits, 96 numbers, different numbers with these 5 digits, and 96 numbers with these 5 digits. Well, so that's about the first question. Now let us move on to the second one. Well, now let us look at the second question here. How many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of the digits is not allowed? So you need a 4-digit number, which is quite straightforward question. All right. So how many digits are available to you? 1 to 9. So there are 9 digits. So 9 digits are available. Out of this, you have to take 4 digits and arrange them. So 4 digits are to be arranged. Now if you want to do that, It is just arranging 9 objects in 4 places. So it's a straightforward question. What is 9p4 NPR formula? So n factorial, 9 factorial in this case, divided by 9 minus 4 factorial. Okay, so that is 9 factorial divided by 5 factorial. All right, so 9 factorial can be written as 9 into 8. So that can be written as 9 into 8 into 7 into 6 into 5 factorial divided by 5 factorial. So you can cancel out this. I know, I'm sure you know this technique, correct? So n factorial is n into n minus 1 factorial. So 9 factorial can be reduced in this way. So you just have to multiply these and check whether the answer is 3024 or you have 3026, 3040, 3014. You just have to multiply them, okay, 9 into 8 into 7 into 6, and that would turn out to be 3024. All right, so you can multiply that and check. I leave that to you. Okay, it is a simple multiplication. You cannot use the calculator, but you should do it manually. Okay, so option A is the answer for second question, 3024. Well, now let us move on to the third question. Okay, so how many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if repetition is not allowed? How many numbers lying between 100 and 1000? That means you need a 3-digit number. Okay, so you need a 3-digit number. Now you have 0, 1, 2, 3, 4, 5. So there are totally 6 digits. So you have to arrange those 6 digits in 3 places. But when you do this, you will have 0 in some numbers. You will have 0 in the first place. So you have to delete, you have to subtract those numbers. For example, you have 0, 100, 0, 1, 2. That is not a 3-digit number. That is not greater than 100. Okay, you have 0, 2, 3, let us say. That is also not greater than. But if you have 1, 0, 2, yes. So 0 can be in the second place, 0 can be in the third place, but 0 cannot be in the first place. So those numbers have to be deleted. How you do that? Fix 0 in the first place and arrange remaining 5 digits in 2 places. So arrange 5 digits in 2 places. Repetition is not allowed, therefore it is NPR formula. Otherwise it would be n raised to r formula. Okay, so we are arranging 5 digits in 2 places if the repetition is not allowed. Now just calculate this. So what is the 3 factorial divided by 6 minus 3 factorial, NPR formula. All right, so NPR is equal to n factorial divided by n minus r factorial. Use that formula here as well as here. And this is like 5 factorial divided by 5 minus 2 factorial, and now that is like 6 factorial divided by 6 minus 3 is 3 minus 5 divided by again 3 factorial. Simplify this. So this is 6 into 5 into 4 into 3 factorial. So 3 factorial can be cancelled, and over here you have got 5 into 4 and 3 factorial divided by 3 factorial. So cancel out that that as well. Now how much is this? 120, correct? Minus 20, that's 100. So this is 120 minus 20, which is 100, and 100 is in the option D. So option D is the answer. So there are totally 100 numbers possible. Well, so that is about question number 3. All right, so let's move on to the next set of questions based on the concept of permutations. We have a few more questions based on arranging the digits, and then we will go to arranging the words and arranging the letters and getting different words from that.
Don't forget to like our video and subscribe our YouTube channel for all the updates.